I'd like to briefly go over this question called count the number of consistent strings. And the main task behind this problem is that we're given a string called allowed, and allowed represents the characters that we're allowed to have in a particular string. And where are we making this judgment? We're making this judgment from this words array, and this words array consists of several entries of words. And the idea is that we want to go through and look at each of these entries in the array, and we want to be able to judge whether or not a particular entry consists of strictly allowed letters. So basically, allowed consists of letters that are allowed, and we have to go through the array and count how many words consists uh, of letters that are allowed. And so you can read the description here, and that is essentially conveying the same thing. You're given a string allowed consisting of distinct characters, and you're given an array of string called words, as we discussed. And a string is consistent if all of the characters in the string appear in the string allowed. So how are we going to do this? What's the approach? The main approach is actually to keep what is called a set. And in this set, we are going to add all of the characters that are visible to us in the allowed string. So add characters from allowed, right? And I'm going to put quote unquote here. And after they've been added to the set, we iterate through the words array and count how many words consist of quote unquote allowed characters, right? Now, how we're going to achieve this is by using the set.contains method. So what we can do is we can iterate through, okay, that's an O of n traversal, and we are going to, for each element that we grab from the array, we're going to basically use set.contains, and that will allow us to say, okay, well, is this particular letter contained in the set of allowed characters? And if they're not, then we're essentially going to return false or what have you. So let's try to build this here. We mentioned that we would have a set of character values. I'll call this set equals new hash set. And so we're going to actually have to iterate through, we're going to have to iterate through the allowed string, and we're going to have to add each of the characters into the set. So how do we do that? Well, there are two ways you can do it. Either you can make a pointer, and you can put that at 0. So in the allowed word or string, we have a pointer at 0, and this pointer is going to move up each, for each character, and it's going to add it to the set, right? So while p1 is less than the length of the allowed word, allowed.length, this is basically gonna take us all the way to the end. So p1 is gonna move up, and then when p1 becomes greater than the length, then we basically want to stop. You could also do a for loop here if that's more intuitive. I is less than allowed.length. I plus plus, both of these would work. Doing it in this manner, we actually wouldn't even need p1, but I'll just go ahead and just do it this way, where we have p1, and that's established at 0. And while p1 is less than allowed.length, we are going to do set.add. That is the API call for adding an element into the set. So we do set.add, and we're basically going to say, okay, well, what do we want to add? We want to add the character allowed.char@. This is another API call for the string name .char@. What this does is it allows you to enter in an index, and then you get the letter that the index is referring to. So we can say p1. So we're adding what P1 is referring to. So now we've effectively added A into the set. So set.add allowed.char at P1. And then we're going to move P1 up. Now, it's not going to, continually move up indefinitely, because we're essentially going to reach a point where P1 is equal to the length, in which case we wouldn't want to process more characters. And then this effectively adds them to the set. In fact, you could even modularize this by, creating a helper function that will add all words into a set, but we don't want to complicate things too much. And now we're going to, let's see what we're going to do. So we're going to iterate through the array. And so here, we're not going to be doing, hugging parentheses. We're just going to have words.length, because words is an element, is an array. And then when you want to access the property for length, when in terms of an array, you just do length I++. And here, what we're basically going to do is we're going to grab each of the words. So we're going to say, okay, well, if now this is sort of the next stage here, is how do we know, because for each entry in the words array, we actually have to go through and check each of the characters and then sort of match that against what we have in our set. So I was thinking to make a modular function here. So we're going to have a public function. We're going to call this contains allowed, right? Now, contains allowed, what contains allowed is going to do, it's going to return a Boolean value, and it's going to take a string. It's going to be, we can call this word, and it's also going to take in a set of character values, right? We'll call this set. So what this is going to do, or what the motivation is up here, we can say if contains allowed is equal to true. If contains allowed is equal to true, or we can just say if contains allowed. What this would allow us to do is it would allow us to just specify contains allowed, and then that basically means the same thing. Saying if contains allowed is true, or saying if contains allowed, both of them try to assert that if contains allowed is true, then do something. So if contains allowed, and we're going to pass in words of I. Okay, and then we're going to increment count by 1. So that means count has to actually exist. Okay, so we're going to say int count is equal to 0. And then we're going to return count. Okay, so it seems like we have a problem here. And then we are going to return count. So if contains allowed is true, then we can increment count. If it's false, we're not going to increment count. We're just going to return count later. So basically, the code is done, right? I mean, we've added all of the characters into the set. We've iterated through the words array, and we have effectively judged whether or not a particular entry in the words array contains the allowed words. And if it does, we increment count by 1. If it doesn't, we return count. But what about this function here, right? This function has to contain the logic behind contains allowed. So what we're essentially going to do is we're going to do something very similar to what we did here. This is basically how you can touch each character, so to speak, right? So while P1 is less than the word.length, okay, what we're going to do is we're going to say, so this is how you can check if something is contained within the set. So, and then you can pass in s.char at P1, right? So if the set contains the character that P1 is referring to in the string, then we can do something. But how about this? The minute I see, I'm going to put a negation sign here. It's going to sort of an exclamation mark. The exclamation mark is basically saying, as soon as I see as soon as I'm touching an element or a character of the string that isn't contained in the set, I'm going to immediately return false. And if I can get through this entire while loop without ever having returned false, then I will simply return true, because then it must have been, so it must have been the case that this was never false, and therefore the opposite must be true. And of course, to process the next element, I actually have to move P1 up, just like we did here. So that's sort of the logic. We add all of the characters into the set. And then and so so we had to create the set in order to do that. And then this is a very popular way of touching each character in the string. We've added that by using the add API. Allowed is the string. Char@ is the API that allows us to touch an element that an index is referring to, P1, and we move P1 up to process the next. So all of this is just adding all of the allowed characters into the hash set. And then we have we're iterating through. We have count to store the count of how many words or entries in the words array satisfy the condition. So if that condition is true, we increment the count. And if it's not, we're not gonna do anything, right? So let's see if this works here. Okay, so it seems like we have if contains allowed words of I. So when we basically used s.char@, and that was here, it was actually word.char@. So that addresses the first error. And the second error is that if contains allowed. So maybe I can't use the word contains. Maybe I'll just reduce this to allowed. Okay, actually, contains allowed is fine. They're not reserved keywords. But remember, in our method definition, we're passing a word. We're also passing a set. And which set are we going to pass in? It's going to be this set here. So what we should do ideally is we should say, contains allowed takes in the word, but it also takes in the set, right? Because it has to be able to, like, which set is this referring to? It must be referring to this set here, right? So we also have to pass in the set in order to, in order to keep it consistent, basically.